Before I go on to some other things, I'd like to go back to our get length and take a look at something in get length. I did it with these characters up here, where it has a pound sign and an exclamation, and then it has bin bash. Now that bin bash is the path to bash on your system, and it says, okay, go run a shell, and then inside the shell I ran awk. Now, I can run anything I want up here at this point. I don't have to run bash. I can run, well, actually, this just has awk in it, so let's run that. Now I'm going to use another command to find out where awk is on the system. And I'm going to replace that with awk. And I happen to know that for awk, if I want to do this, I have to have a -f. And now I take off all of those things, and the program I want to run in awk is just that. So I've skipped running bash, and I've created a thing that says, shell, when you run this script, go out there and run awk. And hopefully, I now have an awk script that just prints the length of each line. Hopefully I get a 3. Okay. And that doesn't run a shell, which what you should take away from this is that this pound bang at the beginning of a script allows you to run any program you want to, and with maybe some options, take the input for the program itself from that file, and build all sorts of things. And you see this all the time with programs like awk, Perl, lots of different things. Now, some programs are not convenient for that. I promised I was going to show you how to do some plotting and some summary. And the plotting tool I'm going to use is GNUplot. And I've prepped a little tiny script that gives me summaries of stuff. I quite often want to summarize some set of data and get some parameters around it, statistical parameters around it. Now, this particular one says, really, I want to, or this is actually graphing as GNUplot, but I also have a R script, the same sort of thing, that takes a single column of data and gives me back statistical analysis on it. The statistical analysis on it is kind of simple, but let's say we want to get our statistical analysis on, I think temp3 was our data. Yep. Which has all these different values in it. And we'd like to summarize it. This is already partially summarized because it's got the counts in it. We want the original data so that we can statistically analyze it. Now, earlier we had our 10 million users and we reduced this to a set of lengths. And we saved that file as temp2. Let's go make certain that that is in fact the case. But yeah, it looks like this is our 10 million, and I'm just editing it in VI. That first big number is our line number. And the second one is our length, and we see that we've got a sorted list of lengths. Now, I can turn this into statistical information with a single line in R that just says read standard in quietly and give me just a summary, which is just min, max, stuff like that. And I can do and I'm not expecting you to know R. It's a full-fledged statistical language that's worth a semester long or maybe 2 or more semesters of statistics and studying it. But I've dug around and figured out that this little thing that I've put in R gives me my min, median, max, and, it gives me some statistical analysis on it. And I've taken a single line, extracted some data, and now I've got some statistics. Now, as I recall, temp3 was our list of frequencies. Let's go look at that. And yeah, that's our list of frequencies, but it's not sorted. Let's actually get this sorted and pick out the 10 most common and see what the graph of those looks like. So if I do sort -n, and now we have it sorted. From the least common to the most common. And let's pick out the last 10 of those. So tail minus 10. Let's make certain we got what we expected, which looks like that. And now let's do a plot. And I have this little single line plotting program that just gives me some boxes, and I can do and I think that's a little bit off the screen here, but let's move it over. And we see we've got a little bar graph plot. Now, all of these things are taking everything from standard in and producing output or processing it. And consequently, when I do this, I can actually tag these things together and just build a single line script that runs these, or you can work through it in temporary files like this. In dealing with big data, lots of times it's more convenient to keep your intermediary results in temporary files. But I can see that, yeah, I've got a variety of different things, but I've managed to produce a little plot so I can look at my data. So what is in GP? Again, GNU-plot is a full-fledged language with plotting capability. But again, I've turned it into, here's how to plot 10 little things with it. And you can dig into GNU-plot and figure out how to use it in detail. And in and of itself, this is maybe not the most useful set of things to know about usernames. Maybe you don't want to know about usernames. But the ability to take these tools that are all batch command line tools and stick them together into a pipeline of processing to quickly extract data, to be able to take that data and manipulate it, to profile it, to look at it, to get answers out of it. And do that quickly and simply is tremendously powerful. And having some understanding, maybe not that this is what I can do with this, but I can look up how to build this particular thing in this tool and this particular thing. And now to be able to join those together is a huge thing. And the big inventions of Unix are the shell and how it works in running processes, the fact that we have these pipes that we can take small things and build into bigger things easily, that we're sitting in here inside a fetch execute machine, running commands, and we can take the output of them, make it the input of something else, we can manipulate it, we can pick out columns, we can take data and mangle it into the form that we need quickly and easily. That's the process that you need to understand. It's not, I'm going to have to learn GNU-plot, I'm going to have to learn. No, it's look at the pipes, look at how it works, and say, yeah, these are really useful things. I can build stuff out of this. And this entire processing system is radically more powerful and different than I'm stuck in a tool, I click, and I drag. So this is the essence of why Unix is a useful tool, why it works well for an awful lot of stuff, and how you can turn that into scripts that you can build bigger pieces out of.